Okay. All right, so we've been given, do you think it's sturdy?
Yeah.
We've been given two ordered pairs. So f of 2 is 3 and f of 4 is 9. What are these? These are points 2, 3 and 4, 9. If we are going to write the equation of the linear function, what do we have to do? Find the slope. M equals what? Well, give me the numbers.
9 minus 3.
9 minus 3, 4 minus 2. Now, it is time for us to stop screwing up the slope. We're big kids now. 9 minus 3, 4 minus 2. So what's our slope? 3. Good. Now what?
Plug it in.
Plug it into y equals mx plus b. So m is 3. Let's use these for y and x.
X is 2.
So y is 3, x is 2, right? So 3 equals 6 plus b, and b equals negative 3. So my answer is not on the board yet. The answer is y equals 3x minus 3. M x plus b. Okay? Now wait, before you take any, let me see if I saved some extra back for the people that are absent all the time. Let me see. Yes, Raven here. And I have a couple of quizzes to turn back too, and a couple of math leads. We'll get those back. We're done here. All right, B, write the quadratic function with a vertex at 1, -2, and containing the point 3, 2. All right, who remembers how to do this? Joseph.
Plug in the you can like the y equals n times.
We know that from the vertex, we know that our equation is y equals something times x minus 1 squared minus 2. You have to remember, in order to do this, you have to remember what your standard form of a parabola is, your vertex form. This tells me to go right 1 and down 2. Isn't that what that vertex means? Go right 1 and down 2. Now, how do we find the end? Plug in the other point, y here, x here, and work it out. Now, what is 3 minus 1?
2.
Squared?
4.
Now, do not subtract the 4 and the 2. The 4 is hooked to an n. So we're going to add the 2 and divide. So it turns out n is just 1. So our answer is y equals 1, x minus 1 squared minus 2. Ooh, number 3. Change to vertex form by completing the square. So in other words, what this means is you're going to take this equation and you're going to make it look like this. Okay, so who remembers how to do that?
5 by 2.
Joseph's all over this. You work on this over the break, Joseph?
Yes.
Good boy.
Yeah. How you feel?
You get the t-shirts back.
Maybe some socks I can find someday. What do we do, Joseph? We'll let you do a couple steps here.
5 by 2.
So everything has to be divided by 2, and that includes the y. Remember, you cannot complete the square if there's a number here. So the first thing we're going to do is divide every single number, including the y, by 2. Then what do we do?
You do like the x or the
Not yet.
Add 2.
You gotta get the 2 moved over to the other side. Okay? Now what?
You divide 8 by 2 and then square it.
Exactly. So now we do the completing the square. So what's half of 8?
4.
4 squared.
16.
So we are going to add 16 to both sides. Now once again, that 16 right there, that thing we added, came from half of 8 squared. Now, we call it completing the square because this now is going to be your squared parentheses. Remember, you need a square. This is it. What will I have in the parentheses?
X plus 4.
X plus 4. And that equals y over 2 plus 18. Because I added the 2 and the 16. Now we got to put it back. So it looks like that. So what am I going to do? Subtract 18.
Multiply by 2.
And multiply by 2. And when I multiply by 2, I multiply the parentheses by 2, but not what's in it. I do have to multiply this number by 2. And there you go. Now, the question said, put it in vertex form. So I am done. That's the answer. That's the actual answer to the question. See how it looks like this one? That's vertex form. When you get it in that shape. All right, any issues with that? Any questions about that? All right, find the vertex axis of symmetry and direction of opening in the manner of your choice. There are a couple of them. Okay, now keep in mind that this is just like the test. So it says in the manner of your choice. So how do you want to do problem A?
Shortcut.
Shortcut? What's the shortcut? X equals negative b over 2a. And that's your axis of symmetry. So your axis of symmetry for problem A would be negative 4 over 2. Does everybody get that? Actually, that's x equals. So that's x equals negative 2. There's your axis of symmetry. Now I want the vertex. What's the vertex? Well, I don't know, but I know x is negative 2. Would you agree with that? Now, how do I get y? Plug negative 2 back into the problem, which I didn't write down. So I'm going to plug in negative 2. What's negative 2 squared?
4.
4. What's 4 times negative 2? Negative 8. So is that negative 7 maybe? Double check, is that right? And which way is it open?
Up.
Up. Because this is a positive 1. Now B is trickier, but actually easier. What's A in this problem? What's A? 3. What's B?
0.
0. B is 0. There is no B. Does everybody see that? And C is negative 8, but I don't need C anyway. So, axis of symmetry, x equals negative B over 2A. What's that going to be?
0.
What did you tell me B was?
0.
0 over 2A would be 6. Your axis of symmetry is x equals 0. Which means your vertex is 0, comma? 0, comma what?
0. Oh, wait. Negative 8.
Negative 8. And which way does it open?
Up.
And how did we get the -8? Those of you that are a little bit behind, how did we get the -8? We plugged in 0 into the equation. Marley, I don't know what you're doing back there, but stop it.
I just asked her a question.
Let's stay focused. Yeah, was it a math question?
Yeah.
Okay, I'm sorry, go ahead. And then I want focused up here, okay?
I've been focused. I was just doing my
All right, number 5. This is one of our variation problems. We have 2 kinds of variation that we're responsible for. One has a formula that looks like this, and one has a formula that looks like this. You need to remember that. And you have to remember which one is which. One of these is direct, and one of them is inverse.
Direct
Which
is
is which?
KX.
This is direct, and this is inverse. So let's read our problem. Temperature varies directly as volume. Temperature varies directly as volume. There's your formula. Instead of y and x, you have T and V, temperature and volume. So that's the first thing. If the temperature is 10, then the volume is 28. Here's my direct variation equation. They told me the temperature is 10, the volume is 28. What good does that do me? What can I get from this? K. So K equals 10/28, which is 5/14. Find the temperature when the volume is 50. Find the temperature when the volume is 50. John's getting out his calculator. He knows what he's going to do now. He's going to tell me what the temperature is. So we'll wait on you, John. Since you're prepared today, thank you very much. What is our temperature? 13.88? 13.89?
So it wouldn't matter if it was in fraction or decimal?
No. All right, or yeah, Chris got a good point. If you wanted to answer it, let's see, it'd be 250 over 14 or 125 over 7. That would be the fraction answer if you wanted to do it as a fraction.
Okay.
All right, now here's the thing about that problem. Notice I did it one sentence at a time. When you get your test, don't freak out and try to jump to the end. You can't answer the question without going through these steps. Step 1, write the equation. Step 2, find K. And then you can answer the question once you've done those other things. Got it? All right, number 6. Oh, this is a big one. We want to consider this problem, list the possible rational roots, and find the factors. Notice I underlined some letters to remind you that possible rational roots are what we have been calling the PRRs. All right? So what are our PRRs? Factors of 6 over factors of 1. Remember, it is last over first. Asia, what you doing back there, honey? You paying attention? Factors of last over factors of first. So that'd be plus or minus 6, 3, 2, and 1 over 1. You okay with that? Now find the factors. Well, what do? Plug in 1, right? I don't think 1 works.
2.
2? Let's try 2. Well, I don't know. Somebody said try 2, so I'm going to try 2. So that's 8 plus 8 minus 10 minus 6. Oh, whoa, 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 good job. 2 works. Now, what does that mean my factor is? Because that's what the question asks for. What are the factors?
X plus 2.
Not x plus 2,
Minus.
x minus 2. Remember, the number that you plug in is the number that you divide out, is the number that you put on the graph. So if you are putting 2 on the graph, then your factor had to have been x minus 2. Why'd I put 3 parentheses up there? Because it's x to the third, and that tells me there's going to be 3 of them. All right, so I'm going to divide it out. There's the 0 that I wanted to have happen. All right, what do I do now? What? What's this?
X squared.
X squared plus 4x plus 3. Does that factor?
Yeah.
How does that factor?
X plus 1, X plus 3.
X plus 1, X plus 3. There are your factors. There's the one you guessed, and then there are the other 2 that we get from our depressed polynomial. Then it's a sketch. Hey, remember how we do this? Very simple. We put some dots on the x-axis. And where will the dots go?
X plus 2.
At 2, and I label it 2,
Negative 1.
-1, and -3. Now I'm going to connect those dots, aren't I? But in order to start, I have to remember how x cubes act when you graph them. Morgan?
Will you count off if you don't label the point?
I will. Not a ton, but a little bit. How do cubes or any odd power behave? They start down and end up. Now remember, so starting down, heading up. When I hit this point, I have choices, don't I? Go through, bounce off, meander. What's going to happen when I hit all of these points?
Through.
Just straight through. They all have to be connected. We're just going straight through. Yep. Oh, whenever I decide to let you go, it's going to be at least another 10 minutes. So let's stay focused. Let's get as much of this done as we can. All right, so number 7. We're going to sketch it. That's all you have to do is sketch it. So like the one we just did, okay, stop. Like the one we just did, we'll put some dots. Where do the dots go?
X plus, or X.
At 1,
2.
at 2, those are close together,
-3.
and at -3. All right, everybody got dots where they belong? We're on problem 7. Now, what's the degree of the thing? How many x's do I have all together? 5. 5 acts just like 3 does. Starts down and ends up. So I'm starting down here. All odds act this way. If there's an odd number of x's, this is how it acts. Now, that dot came from this 0 right here, this factor. Notice that factor is squared. So what does that mean about my graph?
Bounce off.
It bounces off, and then it comes around, it comes up to here.
Bounce.
What does it do when it hits that one, which came from that one?
Bounce.
Bounces again. What's it do when it gets to 2?
Through.
Goes straight through. And why does it go straight through? Because that one isn't squared or cubed or anything. It's just a plain factor. Remember that?
Yes.
Here we go again. Now we get to factor and sketch again. This one's a little bit different though. Look at the problem very carefully. Do you notice anything about the problem?
Yeah. The x cubed.
Well, it has an x cubed, for sure.
Oh, you can factor.
You can group it, can't you?
Grouping.
So we don't have to list all the PRRs and do all the factor or all the whatever. We don't have to do all that. All we need to do is group it. So what can we take out of the first 2? X squared. Now be careful. What can you take out of the last 2? Negative 9. And what does that leave you with if you pull out a negative 9?
X plus 4, what's that?
X plus 4. Perfect. All right. So now, what's my common factor? X plus 4. So I write it down. I don't square it. I don't do anything to it. I write it down. And then in parentheses, I have x squared minus 9 because that's the part that's not the common factor. And what do we know about x squared minus 9? X plus 3, x minus 3. Now we're going to sketch it. Anything bouncing in this problem? Nope. So it's all going straight through. So put your dots on there. You have one at negative 4 and negative 3 and positive 3. Now it's another third degree. How do third degrees start?
Start down.
Start down. So here we go, starting down. You told me nothing bounced, so I'm just going to connect all those dots, and there we go.
Does it matter how high you go?
Nope. Nope, it does not. Remember, your hills and valleys can be as high as low as you want them. When you get to calculus class, you will figure out how to tell that. But right now, we're just sketching them in. List the possible rational roots. Find the roots. All right, here we go. List the possible rational roots. What are they? What'd you say?
Plus or minus 1.
That's it. Plus or minus 1. That's all we've got. Little tip. Don't buy this green stuff. It's not very good. All right. Plus or minus 1. All right. So let's put in 1. Does 1 work, Marley? Did you try it?
Yeah.
It does work. Your only guesses this time are 1 and negative 1. We just tried 1 first and it worked. So now we'll divide it out, right? Remember our steps. We divide it out. You two need to shut up and pay attention. So here we go. Alrighty. Where do we go from here? Paul?
X squared plus 3x plus 1.
Perfect. Well, shooty tooty. That does not factor. What am I going to do since it doesn't factor? Austin, got an idea? Oh, go stretch at the wrong moment. What do you do if a quadratic won't factor, but you still need to solve it? What do you do? Think about my socks. Use the quadratic formula. Your job in this problem, kids, is to find the roots. You have found one. One of the roots is 1. There are 2 more. Remember, you need 3. The other 2 are going to come from this equation. Everybody see that doesn't factor? So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you have forgotten the quadratic formula, get it or learn again. Come on now. We're educated people. We know our quadratic formula. So we have negative 3 plus or minus what's under there?
2a.
Well, what's under the radical?
5.
5. And nothing cancels or simplifies or anything. So there are the 3 answers to the problem. Does everybody recognize there's 3 of them there with the plus or minus? That counts as 2. You can write them together, or if you want to pull them apart, you can. Negative 3 plus root 5 over 2 and negative 3 minus root 5 over 2. Now, normally, most of our problems, when we got to this point, we could factor. And if we can, that's awesome. But we couldn't, so we used the formula.
This fourth one. Are we probably going to see one of those on the test?
Like what? Like the one we just did? Okay, remember, the practice tests are just like the test.
This will be number 9 on the
Well, I'm not sure they're in exactly this order, but there will be one on here. I can't remember if I put them all in the same order or not. I kind of mix things around. Okay, here we go. Let's get a couple more done, then we'll go to lunch, okay? Number 10. Actually, you know what? We'll make number 10 your exit ticket.
Oh, jeez.
So get her done right now on your own. It's number 10. Bring it up to me.
No, I do this one, actually.
If you forgot how, ask your neighbor. Maybe your neighbor remembers. Oh, do we all forget?
Look at your coordinates. No, I got it.
Let me do it.
Ethan's
got it.
Oh.
Ethan's got it? All right, we'll let Ethan do it. Talk to each other, sort it out. Oh my gosh, I didn't label my points either. That's very bad.
That's points off before.
Points off.
Alright, next step.
Oh, no.
I think I remember.
Did you remember to set up parentheses?
Yeah.
And what were your parentheses? X plus 4.
X plus 1
plus 1
squared.
Oh,
X
squared.
minus 3. Okay, hold off on that. You're right. But does everybody get these parentheses? This is the starting point. Now, we're going to find this number that's missing out here in front, but before we can do that, you have to pay attention to a couple of things. Look here. What's happening here? Kids, what's happening at these 2 points?
Bouncing.
We're bouncing. So this one and this one are squared. Everybody okay with that?
Mm-hmm.
Now, how do we find that missing number?
Plug in 2 with 10.
Plug in 2 for every x. Every x gets a 2. And the y gets a 10. common thing to forget it. Try not to. I got 5/27ths for my n. Did you?
Yeah.
If you got 5/27ths for your n and you wrote this down, because this is the final answer. The equation is the answer. What's in the box is the answer. As soon as you get that written down and that makes sense to you, you can take off for lunch. I want everybody back in his or her seat by 12:22. Everybody's back in your seat by 12:22. Got it? Does it look familiar now?
I know.
Chris, can you pop that off? Thank you.